Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 6 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a basic triangle here, TRW. It's going to be dilated by a scale factor of n. All right, so we don't know what that number is. The origin is the center. So we're going to create T prime, R prime, W prime. We don't actually need to draw that. Well, we can't because they don't even tell us what the scale factor is. It's literally just a variable, n. So we need to find an ordered pair that best represents the location of point R prime. Well, first, let's find what R is. All right, so R is -3, -5. All right, so we've got -3, -5 in all of our answer selections. We cannot eliminate any of them like that. Look what we're doing with n. We are either dividing by n, or we are either multiplying by n, we are either adding n, or we are subtracting n. So we're just going to throw all 4 operations at you. So that doesn't help you either. So if we wanted, let's just make n something, right? Let's say n equals 10. Okay, so let's make it big and obvious. All right. So if we wanted a scale factor of 10, that means we're going to make this 10 times as big. It's going to be huge. Like, it's going to be off the screen. It's going to be much larger than this particular coordinate grid can handle, but I want to make it much bigger. Okay, so let's see what happens to -3, -5 in all of these. If we make n equal 10, right? So look at this. If I do -3 over n, which is my 10th, and then -5 over n, which is my 10. Well, I just turned -3, -5 into -3/10, -5/10, which is like going to be the world's smallest. I think that just made it 10 times smaller. So that actually has the inverse effect. I made it times 10 to make it bigger and ended up making it huge. I don't think that's going to be the answer. -3 times n, so I'm going to make that just 10. -5 times n, which is 10. So that's going to turn into, there we go, -30, -50. All right, that would be massive. I'd be way off the scale. So far down to the bottom left, it's not even funny. That could possibly work. All right, let's see if I add -3 plus 10, -5 plus 10. So that's going to equal -3 plus 10 is, it's like 10 minus 3, 7. 10 minus 5, 5. So that ends up putting me, that's weird, like up here somewhere. So you know what would actually happen if you added or subtracted for this case? All you do right here, I'm going to go ahead and just mark these ones out, because you do the same thing for j, just move it in a different direction. These are actually called translations. We're actually not changing the size, we're just shifting it, right? So if I'm adding 10, I'm going to kind of shift it to the upright. If I'm subtracting 10, I'm going to shift it down to the bottom left. You're just sliding it, but you're not making it larger or smaller. Look what made it larger or smaller. And you know what? If we go back to the problem, the answer's been staring at us the whole time. By a scale factor. When we do 3 times 4 equals 12, what are these two things called right here? Those are called factors, right? The answer is called a product. Factor means multiplication, so we need to multiply, and our answer here is G.